Look outside tonight. Pick any direction, any window, any view. Somewhere beyond the clouds, beyond the moon, beyond the faint smear of the Milky Way. 1,400 light years away. There is a planet orbiting a star. A planet with a year almost exactly as long as ours. Orbiting a star almost exactly like our sun. In a zone where water could remain liquid, where oceans could exist, where life, as we understand it, could have had more than enough time to begin, and we almost missed it entirely. Tonight we trace the story of Kepler 452b, the world that made the entire human race stop, and ask a single question. Are we alone? Let's begin. For most of human history, we did not know if other planets existed beyond our solar system. Not really. We assumed they did. The mathematics suggested they should, but assuming and knowing are very different things. The first confirmed detection of a planet orbiting another star did not happen until 1992, then 1995, then dozens, then hundreds. Each new discovery revealed the same overwhelming truth. Planets are everywhere. The universe is full of them. But finding a planet is one thing. Finding the right kind of planet is something else entirely. Astronomers were searching for something specific, rocky, roughly Earth-sized, orbiting at the right distance from the right kind of star. Not too hot, not too cold, a narrow region known as the habitable zone, sometimes called the Goldilocks belt, the thin strip of space where liquid water can exist on a planet's surface. Because liquid water, as far as we know, is where life begins. The problem was scale. Our galaxy alone contains somewhere between 200 and 400 billion stars. Checking each one individually with the tools we had would take longer than the universe itself has existed. We needed a different approach. In 2009, NASA launched a spacecraft called Kepler, not to visit planets, not to photograph them, just to watch. Kepler fixed its gaze on a single patch of sky in the constellation Cygnus, a slice of the Milky Way containing roughly 150,000 stars, and it stared continuously. For years, every 30 minutes it measured the brightness of each star with extraordinary precision. It was hunting for a specific signal, a tiny rhythmic dimming, the faint shadow that appears when a planet crosses in front of its star and blocks a fraction of the light. This technique is called the transit method. When a planet passes in front of its star from our point of view, the star dims by a fraction of a percent, briefly, regularly, like clockwork. The same signal repeating every time the planet completes one orbit. The dimming is subtle. Detecting an Earth-sized planet crossing a sun-like star from our distance is roughly like detecting a searchlight dim slightly, because a gnat flew in front of it. But Kepler was built for exactly this, and it watched, patiently, relentlessly, processing the light from 150,000 stars every 30 minutes for 4 years, and buried in all that data, in one star's quiet rhythmic signal, it found something. The star is called Kepler 452. It sits 1,400 light years away in the constellation Cygnus. To the naked eye, it is nothing, invisible, just one of billions of faint points of light. But to Kepler, it was interesting, because every 385 days, like clockwork, the light from Kepler 452 dipped, just slightly, just enough, the same dip, the same duration. Something was orbiting this star. Something was crossing in front of it. Something planet-sized. The Kepler science team identified the transit signature in 2014. They spent a year analyzing it. On July 23, 2015, NASA made it official. The planet was designated Kepler 452b. NASA called it Earth's bigger, older cousin. This was the first near-Earth-sized world ever confirmed orbiting in the habitable zone of a G2-type star, a star like our Sun. That had never happened before. Let's talk about what Kepler 452b actually is. The planet is about 60% larger in diameter than Earth. That makes it what astronomers call a super-Earth. Its orbital period is 385 days. A year on Kepler 452b is only 20 days longer than a year on Earth. It orbits its star at a distance of about 1.04 astronomical units, nearly identical to the distance between Earth and the Sun. Because of this, the amount of light and energy reaching its surface is remarkably close to what we receive here, not identical. Its star is slightly more luminous, but close enough that, in principle, liquid water could exist. Its estimated equilibrium temperature is around 265 Kelvin, about -8 degrees Celsius. Chilly by Earth standards, but well within the range where the right atmospheric conditions could produce a habitable surface. There is one crucial uncertainty. We do not yet know if Kepler 452b is rocky. At 1.63 times Earth's radius, there is genuine scientific debate. Planets in this size range could be rocky super-Earths, dense, geologically active. Or they could be mini Neptunes, small rocky cores wrapped in thick envelopes of gas and ice, entirely inhospitable to life. If it is rocky, the physics become fascinating. A planet 60% larger than Earth with a rocky composition would have roughly 5 times Earth's mass. 5 times the mass means nearly twice the surface gravity. If you weighed 70 kilograms on Earth, you would weigh roughly 130 kilograms there. The atmosphere would press down more tightly. The planet would likely have thick cloud cover, dense, misty, wrapping the surface in a permanent haze visible from space. But there is a shadow hanging over Kepler 452b, a slow warning written into its star. Kepler 452 is remarkably similar to our Sun, a G2-type star, almost the same mass, almost the same surface temperature, but it is older, significantly older. Our Sun is about 4.6 billion years old. Kepler 452 is estimated to be around 6 billion years old. 1.5 billion years older. Stars do not remain constant over their lifetimes. They slowly brighten. They grow slightly larger, slightly hotter, slightly more luminous. Our Sun has already brightened by about 30% since it formed, and it will continue to brighten. Here on Earth, that gradual increase will eventually push our planet toward the inner edge of the habitable zone. In roughly 1 billion years, Earth's oceans may begin to evaporate. In a few billion more, our planet could become uninhabitable. A scorched world, blasted by a star that has grown too bright. Kepler 452b is already living that future. Because its stars further along in its life, the planet is receiving about 10% more energy than Earth receives from the Sun. And that number is rising. If the planet is rocky, if it has water, if conditions were right, life there would have had more than 6 billion years to emerge, longer than life has existed on Earth. But the clock is running out. Eventually, the same fate that awaits Earth will reach Kepler 452b. It might already be too late, or it might not be. We genuinely do not know, and that uncertainty is staggering. We are looking at a planet that has had more time for life to develop than our planet has existed, and we cannot see it clearly enough to know if anyone is there. 1,400 light years. Let's make that real. Light travels at 300,000 kilometers per second. In 1 year, it travels nearly 10 trillion kilometers. And Kepler 452b is 1,400 of those years away. The light reaching our telescopes right now left that system around the year 600. What is happening there today, in this moment, we cannot know. If a civilization there is looking back at us right now, they see Earth as it was in the 7th century. No satellites, no cities glowing at night, just a quiet blue world. And even if they sent a signal toward us today, we would not receive it until the year 2825. We found Earth's cousin, and it is profoundly unreachable. And yet, it changes something, because we found one world, one. A planet that ticks almost every box. Rocky, perhaps. Habitable zone, yes. Sun-like star, yes. And we found it in a tiny slice of one galaxy containing hundreds of billions of stars. There are trillions of galaxies in the observable universe. If this is how rare it appears, then what does that imply about how many may truly exist? The mathematics point in one direction. We are likely not the only ones.